Two of the following videos are true, while the other one is trash. Can you spot the fake? Season 4, Episode 4. Round 1, let's begin. This is an exposed Tesla coil that produces visible arcs. You can see it much better when I turn the lights off. If I take a small latex balloon that doesn't conduct electricity well and blow it up, and then carefully stab the needle of the exposed Tesla coil through the base of the balloon won't pop, and I can turn on the Tesla coil and see the arcs inside the balloon. With the lights off, it's even easier to see, and you might notice that the balloon starts to inflate due to the buildup of static charge inside. Speeding this up, and you see that the balloon will grow to be quite large over time. Removing the balloon, and you've successfully inflated it using electricity. First up, take a battery pack with 3 AA batteries and some exposed wire, and wrap the negative terminal, or the black wire, around the short lead of an LED. Next, use a helping hand to orient the LED over the glass beaker such that the LED is straddling the lip of the beaker. Next, take some distilled water and pour it into the beaker, filling it up. I spilled pretty badly, so I had to take a second to clean up the water. Next, if I turn on the battery and take the exposed positive wire and dip it in the water, you see that the LED doesn't light up because distilled water is a terrible conductor of electricity. However, if I add some salt to the distilled water and stir it so that the salt has time to dissolve, now if I dip the red wire in the water, the LED will light up. First up, take a AA battery and glue a small thumbtack to the side sticking up. While that glue dries, take a sheet of aluminum foil, draw the outline of a circle on the foil, and then cut out that circle with some scissors. Take another thumbtack and poke a hole in the center of this circle. Next, now that the glue has dried on the battery, attach some strong neodymium magnets to both sides of the battery with their north poles facing the same direction. Now if you place the aluminum foil on the tack that's attached to the battery, the foil sheet will spin around like this. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. It's true that placing aluminum foil on the tack of this battery with magnets will cause the foil to rotate. The conductive aluminum foil completes the battery circuit when it touches both magnets. The current flowing induces a magnetic field that interacts with the magnetic field of the permanent magnets on both ends, causing it to spin. It's also true that adding salt to distilled water makes it conductive, which allows the LED to light up. Although you can poke a balloon near its base and turn on the Tesla coil to produce arcs inside the balloon will absolutely not inflate during this process. I actually filled up a larger balloon, added some tape, and poked several holes in the balloon so it would slowly deflate. Then I carefully placed it on the Tesla coil, trying to match its orientation to that of the original balloon. Now turning on the coil, you see the arcs, and those holes I made earlier will cause the balloon to deflate over time. So I took this clip and put it in reverse to make it look like it was growing. I swapped out the clip with the original balloon with this reverse clip during the transition where I turned off the lights. And yes, it took me quite a few tries to get all the variables right to make something somewhat believable. Here's a quick recap to help you follow before moving on to the next round. Next up, it's time for round 2. First, take a glow stick, crack it, swirl it around a bit, and then cut it open. Next, pour the liquid into 2 different beakers, and you'll see that both will glow at roughly the same brightness. Next, take an ice cube and place it in one of the beakers and stir it up. After a few moments, you can clearly see up close that the beaker with the ice cube will glow much brighter, although it won't glow for as many hours if you do this. Here's a 3D printed structure with a nut glued to the top so I can thread a bolt on and twist it to adjust the height of the bolt. Next, I'll take a strong neodymium magnet and place it on the head of the bolt. Here's a tiny cube magnet that will of course be attracted to the magnet that's attached to the bolt. Next, I'll take 2 solid bismuth cubes and stack them on top of each other like this, leaving a small gap between them. If I place the cube magnet between these cubes, it rests on the bottom since the magnet isn't close enough. However, if I twist the bolt to lower the magnet to just the right height, the magnet will be lifted up and levitate between the 2 bismuth cubes, as you can see here. First, take a long skinny balloon like this and stretch it near the opening. Then fill up the balloon with a small amount of air and tie off the balloon. Then tape the balloon down to the table. Next, on the other side, grab a section of the balloon and stretch it out a few times to weaken the balloon in that spot. Now if I grab the air pocket and squeeze it from all sides with a closed fist, the air pocket will immediately jump to that spot that I stretched out on the balloon. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. If you thought you could use 2 bismuth cubes to levitate a small magnet like this, well done, because this is legit. Bismuth is a material with a really strong diamagnetic force relative to others. Diamagnetism is a repelling force that is typically quite weak. However, as I've shown before with graphite, which is another material like bismuth that is very diamagnetic, a very thin piece of it can be repelled by magnets and levitate. However, that's because it's so thin and lightweight that it can overcome the force of gravity on its own. This cube magnet is much heavier, and the diamagnetic force is not enough alone to levitate the magnet. That's where the top magnet comes into play. When the top magnet is close enough, it will lift up the magnet. However, I don't just want it pulled up, I want it to levitate, which is where the second bismuth cube above it plays a role. With that cube on top, there's a weak diamagnetic force repelling the magnet in both directions. Then once I lower the top magnet enough to roughly cancel out the force due to gravity, now the diamagnetism has the predominant impact. It's cool how stable this is, and I was actually made aware of this because of this structure that I bought, which works the same way with a threaded magnet at the top and a bismuth filling to allow you to levitate small magnets that come with it. This structure was one of the products in this year's Cool Gifts for Science Lovers series that I do, so check out that video or my other guides from prior years to see many other cool gift options this holiday season. Anyway, stretching a portion of the balloon on the other side of an air pocket does allow you to squeeze it and immediately send it to that spot. You don't have to tape it down, and you can keep squeezing each side to send it back and forth. Placing an ice cube in glow stick fluid does not make it glow brighter. I actually added a bit of dish soap to the ice cube while you weren't looking. It's actually the dish soap that makes the glow stick fluid glow more brightly. Adding some soap to the other beaker directly, and now you can see it glows at a similar brightness. Here's a quick recap to help you follow before moving on to the next round. Now it's time for the final round, round 3. If you take a long string of beads in a cup and toss one end off a high surface, the beads will initially get pulled up and out of the cup near the brim. But once you get towards the end of the string, it'll look like this, where the beads reach really high in the air before falling. First, take a rectangular piece of aluminum foil and wrap it around a metal rod, leaving a small gap towards the top. Next, take 3 popcorn kernels, place them in this pocket, and seal up the aluminum foil by twisting and folding the tip. Next, get an inclined surface and attach the rod to a stand so that it's pointing slightly upward. Now, if I use a torch lighter to superheat the kernels, rather than pop, the kernels will immediately burst into flames, causing the aluminum foil to fly off the rod. If you take a long strip of white Gorilla Tape and carefully fold it and stick it to itself, now you can take both ends and rip it apart. This process actually produces some visible light, and if you turn off the lights, you can see it in person. Unfortunately, my camera was having a tough time picking it up, so I instead took a 4-second long exposure photo, and now you can see the blue light that's produced by pulling apart the tape. You've now seen all 3 videos, and it's time to pause to vote in the comments for which one you thought was fake. Dropping beads on a string like this does cause the beads to reach really high above the cup, and it looks awesome in slow motion. This effect is called the mold effect, and it was discovered by the YouTuber Steve Mold, so check out his videos to understand why this works. Pulling apart strong Gorilla Tape like this also does produce visible light, and this phenomenon is called triboluminescence. Placing popcorn kernels in some aluminum foil does not cause the aluminum foil to fly off the rod like a rocket when it's heated. I actually cut the tips off some matches and replaced the popcorn kernels with them while you were blinking. If you want to help support the making of more episodes, consider purchasing my 2 Truths and Trash Science Trivia deck. There's 50 new rounds in the form of science trivia where you have to spot the misconception. I've gotten great feedback that it makes for a fun activity to play with friends and family, and it's a great stocking stuffer or gift for this upcoming holiday season. Thanks for watching to the end. If you enjoyed this video, please like, share, and subscribe, and I'll see you next time.